In this problem, we're going to use the rational roots theorem to fully factor the following polynomial. Let's factor f of x equals 2x to the fourth plus 5x cubed plus 3x squared minus x minus 1. So the first thing that we need to do is we need to list all of our possible rational zeros. And if you remember from the rational roots theorem, those are all of the numbers, positive or negative, who in the numerator come from all of our factors of our constant term. Okay, well, the only factors of 1 are 1 and negative 1, so plus or minus 1. Divided by, in the denominator, any factors of our leading coefficient. So the only numbers that are factors of 2 are 1 and 2. So the only possible denominators we could have are a 1 or a 2. I made my fraction way too big, so let's shorten this just a little bit. There we go. Okay, so what this means is we could have positive or negative 1 and positive or negative 1 over 2 as our possible rational zeros. So this is the list that I'm going to draw from when I'm checking to see which work. Okay, so let's move to the checking part. When we check and see which of these rational zeros work, we usually use synthetic division because it's faster. So when we go to check, let's say first number, let's say x equals 1, to do synthetic division, I'm going to put that x value in a box in the upper left-hand corner of the problem. And outside of that box, I'm going to write the coefficients of the polynomial I'm dividing into. So that would be 2, 5, 3, negative 1, negative 1. Okay, bring down the 2 below the answer bar, and then multiply everything below the line by the number in the box. So 1 times 2 is 2. And write that underneath the next number. Add vertically, 5 plus 2 is 7. Again, multiply every number written below this line by the number in the box. So 7 times 1 is 7. I'm going to write that underneath the next number. Again, add vertically, so 3 plus 7 is 10. Multiply the 10 by the number in the box, which is 10 times 1 is 10. Add vertically, negative 1 plus 10 is 9. Multiply the 9 by a 1 to get 9. Add vertically, and we get 8. And again, if you remember from synthetic division, this is our remainder. And if this were to actually be one of our rational roots or our rational zeros, the remainder would be 0. So since our remainder is not 0, x equals 1 does not work. And I like to kind of keep a tally as I'm going of the roots and the not roots, just in case. So we just figured out that x equals 1 is not a root. Okay, so let's check a different one. Let's check negative 1. So I'll put negative 1 in the box. I'll put 2, 5, 3, negative 1, negative 1. I'm going to go a little more quickly on this synthetic division. I have a video specifically on synthetic division, so if you're interested in how to do this in more detail, check out that other video. But I'll bring down the 2 to get started. Negative 1 times 2 is negative 2. 5 minus 2 is 3. Negative 1 times 3 is negative 3. 3 plus negative 3 is 0. Negative 1 times 0 is 0. Negative 1 plus 0 is negative 1. And negative 1 times negative 1 is positive 1. And thank goodness, negative 1 and 1 is 0. Wonderful. So that tells us not only does negative 1 count as one of our roots, but now we can also use this smaller set of numbers for our synthetic division, instead of the 2, 5, 3, -1, -1, we could use the 2, 3, 0, 1, -1. Don't worry about the remainder, but we could use this smaller version. Now, one very important thing to remember is, after figuring out something that does work, one of your roots, not only do you want to check your next number with 2, 3, 0, -1, but you want to check -1 again. Every once in a while, you get a root that appears twice, like maybe you have x plus 1 parentheses squared. And if you check -1 again, you'll be able to tell if that happens. So again, I'm going to bring down the 2. -1 times 2 is -2. 3 plus -2 is 1. -1 times 1 is -1. 0 plus -1 is -1. And -1 times -1 is +1. -1 plus 1 is 0. That's awesome. So I know that -1 appears 2 times as a root. And keep in mind, since we have 2x to the 4th, I will have 4 roots. If I count all of the numbers, even if they appear multiple number of times, if I count those as 2 of my roots, I should have 4 total answers. So now I've got 2 of them. I've got -1 and -1. Also wonderful, if you get a little bit concerned about going to the fractions, look at this. This answer right here is the polynomial, or this leftovers is the polynomial 2x squared plus 1x minus 1, or more cleanly, 2x squared plus x minus 1. Now, if this continues to factor, go ahead and factor it. If you don't want to use synthetic division, go ahead and factor this. If it does not factor, you can also use the quadratic formula to figure out what the other roots are, which would be really critical if the roots happen to be irrational numbers. This only checks for rational numbers. Say you have square roots of 7 or 5i. Those would be irrational numbers. We'd have to use the quadratic formula. For this one, however, 2x squared plus x minus 1, this in fact does factor, and it factors to 2x minus 1 and x plus 1. So what that tells me is I have x equals 1/2 as another root. Oh my goodness, and x equals -1 for a third time as a root. Notice this gives me 1, 2, 3, 4. 1, 2, 3, 4 roots, and that is exactly what I'm looking for. So let me write the answer down and then summarize what we just did. Our answer would be to factor the 2x to the 4th plus 5x to the 3rd plus 3x squared minus x minus 1. Going off of this information, that would tell us f of x equals x plus 1 to the 3rd power, because I have 3 x plus 1s, times 2x minus 1 from this down here, from the x equals 1/2. If the question is asking just for the roots, then the roots would be given by x equals -1 with a multiplicity 3, and x equals 1/2. It depends on what the question was asking for. Okay, so just to recap, we're going to start by listing our possible rational zeros, using synthetic division, looking for remainders that are equal to 0 to find out one of our roots. Once you get a root, once you get a 0 remainder, do 2 things. Check that same root again in case it appears more than 1 time, like this one did. Furthermore, when you get down to 3 terms in front of a 0 remainder, stop. Then you can convert this into its quadratic form and factor it, or use the quadratic formula to finish finding your roots.